Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Let's go. Current electricity. The electrons are negatively charged particles in an atom. In a conductor, there are many free electrons which possess energy to move from one atom to another. The electron movement in an atom or between atoms are irregular and non-directional unless a potential difference is created between the ends of a conductor. The electrons move through a conductor due to the application of voltage or potential difference across the two ends of a conductor. This causes the electrons to move from one end of the conductor to the other. As per convention, the flow of electrons is from the negative to the positive, whereas the electric current flows from a higher positive potential to the lower negative potential. Importance of current electricity. When an electric current flows, the flow of electric charge is carried out by electrons in a conductor, ions in an electrolyte, and electrons and ions in an ionized gas. This flow of electrons is called as an electric current. When electric current passes through a conductor, it creates heat and light, as seen in filament lamps called as the Joule heating. The flow of electric current through a conductor also creates a magnetic field around the conductor through which it travels. Thus, it's used in coils, transformers, motors, alternators, generators, induction cookers, etc. The unit of current is the ampere and its symbol is capital A. The electric current is measured by an instrument known as an ammeter. There are two types of electric current and they are direct current and alternating current. Direct current. When the movement of an electric charge is in one direction, it is called as a direct current. This is a source of voltage where a continuous unidirectional flow of electron happens. The flow of charges in direct current is constant. The electrons move in a single direction when the potential difference is applied. The waveform of a direct current is a straight line. Direct current is produced by power cells, battery, solar cells, thermocouple, etc. The current flows from one pole of the power source to the other through a circuit. Below is the symbol of a multi-cell battery. Alternating current. When the moment of electric charge reverses its direction periodically, it is called as an alternating current. The waveform for an alternating current is a sine wave. This is a form of electric current available to homes, offices, businesses, etc. The frequency of alternating current available from the grid is 50 or 60 Hz. It is a source of electric power for powering electric lamps, fans, television, fridge, kitchen appliances, etc. Alternating current is produced by alternators, generators, dynamos, etc. The signals from audio and radio circuits are also examples of alternating current. There are also other waveforms of alternating current, such as triangular and square waves, used in various applications. The symbol for an alternating voltage source is shown below. Voltage or potential difference. The voltage or potential difference is the difference in electrical potential between 2 points. The difference in electrical potential of 2 points of a static electric field is defined as the work needed per unit of charge to move a test charge between 2 points. The electrical potential between 2 points are created by an electric charge, electric current through a magnetic field, time varying magnetic field, or a combination of the above. The unit of voltage is called as volt, represented as capital letter V. The instrument used to measure voltage is called as the voltmeter. The symbol for a voltage source is shown below. When a potential difference is created by a voltage source, the electrons flow from one end of the conductor to the other. By convention, this causes a current to flow through the conductor from the positive to the negative end. The flow of current through a conductor produces heat and light. It also causes magnetism around the conductor through which it flows. Now I am going to demonstrate these properties of current flowing through a conductor. Here we have a battery, that is this is a project battery. It's a PP3 type of battery, and we also have this battery clip which you can place on top of this battery. So here it's been in place. Now we have two terminals that is coming from the top of the clip. Now this initially we'll check the voltage. We have the multimeter here, that is where we can turn the position to the 20 volt range, DC 20 volt range. Now we'll check the voltage. This is a dry cell you can see, and here I am going to connect both the terminals of the battery, and here the multimeter is showing voltage around 9.28 volt that is produced from the battery. So it's 9.27. No, it's 9.27 volt. Now we'll just connect a wire to this. I'll connect a wire to the positive terminal, and we'll see whether we can light a bulb with this terminal. So now I'm keeping the other end of the conductor to the bulb here, and just keep it very close to the opposite terminal. So now this bulb is glowing. So this is how the current is passing through the conductor, and it is showing the heat, the light and heat. It's called as Joule heating. It's Joule heating. Now we also have many many LEDs. Here you can series connectly you can connect a series 1 kilo ohm to the end of the terminal, and you can connect it with the LED. Here the LED is it should be connected to the positive end should be connected to the anode. That will be the longer terminal. Here we will connect it to the anode end of the LED, and the other end will be connected to the cathode. Here the LED is glowing. So now this shows that current is passing through the LED, and it's lighting up the LED. Now we'll connect this DC source to a motor here that I have. It's a motor that I am having here. You can see the motor, and these are the terminals, the wire terminals that is connected to the motor. And here I'll just connect one terminal to this side. to the negative side and the other end to the positive terminal of the battery. Now this motor is running. So this shows that current flowing through the coils inside the motor is turning the motor. It is driving the motor, because this produces a magnetic field inside the motor. The running current that is flowing through the coil inside the motor is creating a magnetic field that is causing the motor to turn. So this is another property of the current flowing through a conductor. Let us now check the current consumption for different devices like LEDs and bulb and motor and things like that. Let us see how we can check the current. So initially we'll put the knob of the multimeter in the current in the 10 amp level. So we'll put this in that position and we'll check by we'll connect another terminal of the battery to the negative terminal of the battery here. And now we have connected the negative terminal of the battery with the common port of the multimeter. With the common port of the multimeter here. And now we'll have to change the position of the port to positive port to the 10 ampere range. Now we'll connect a bulb in this position in the positive and the terminal of a bulb. Disconnect. And now we can see the multimeter is showing 0.38 ampere. It's showing 0.36 ampere. The bulb is taking 0.36 ampere of current. So this is the current that is being consumed by this bulb from the battery as a source. So this is how we can measure current that is consumed by a device that is connecting its series. It is connecting its series with the terminals of the device and the battery and the source or the source. Similarly, we can also connect LEDs and for that you'll have to connect the source of the terminal with the multimeter, and you have to put a series resistor here. It's a 1K resistor, and you can connect it to the negative end, that is a cathode end here, and you can connect the anode to the positive terminal. The cathode is connected to the negative part and the anode is connected to the positive terminal. Here you are not able to see the ampere, and so that you have to change the position to the this milliampere range. So we'll have to change the knob to the milliamp range. Then we'll connect the LED. So it shows around 5.7 milliamp current, showing around 5.7 milliamp. This LED is consuming around 5.7 milliamp of current. You can similarly check the current rating for a motor also. Here we have a motor. That is that will connect it to the source. It's running. The motor is currently running, but the ampere level is not too. It's very lower. It's in the lower range, so we need to plug it in the right position, in the 10 ampere position. So we'll change the node here and then reconnect the terminal. Now this is showing around 0.23 amp of current. So that is how we are able to measure the current of various devices by connecting it series to the power supply.